Mr. Truck here with Ford at the new F-150 launch. This is day 2, and today we are still near Sacramento. We're going to go out and pull trailers off-road, get in the mud, get dirty, and have a lot of fun. So join me for day 2 of the launch for the F-150 2015. Okay, I'm here with Pete Reyes, I'm sorry. And you are like the big shot with Ford. You are what?
I'm chief engineer for F-150, but that's not a big shot.
Oh, that's big cheese.
That's a wonderful position to have, but
well, we're going over the components of the F-150. There's so many new things on it, and I was trying to get down to the meat of it. On the front end, you've changed the lower arm is made differently.
Yeah, it's still stamped steel, but this time it's higher strength steel, lighter weight construction, more controllability. We've also changed the way we attach the shock, but the fundamental geometry of the front suspension is the same that we have today. It's a great front suspension.
Okay.
Big news is in the rear suspension.
Yeah, and then you've gone to a shorter leaf.
Yeah.
And I think that should help with squat on trailers, I'm thinking, because longer leaf used to be better ride and more squat.
Right.
So now your trailer should not dip as much.
You know your stuff. There's a number of reasons for the change. It was better for squat. Most importantly, we spent a lot of time when we got a chance to do the all-new architecture to change the engine angle and change the angle of the differential and how we positioned that and how we wanted that to arc. The spring geometry was not only about squatting, but arcing that for a minimum differential change. That allowed us to do a lot of single-piece drive shafts, where in the past we do two-piece. Takes weight out, avoids coupling, and under heavy trailers, as you know, we've got much heavier trailers this time around, avoids that startup shudder.
Oh, well, that's good, because that's been a problem. And I thought that was pinion angle from squatting, and you get into level and all that.
Pinion angle right from the start, you're right.
Yeah, that's interesting. When I heard that your gower, which you're using the same Sterling axle, so your gower is lowered. I can't figure out why you would lower it when you're using all the same bearings and everything. You'd think that'd be one of those big numbers you guys like to get. But
well, the gower is, the limiting factor on the gower, and the gowers we've chosen are the spring rates. And the spring rates that you need to carry the load that you're going to put back there. So the payload is up, but the payload isn't, the payload is up, and we didn't change any of the mechanicals. Same brake size, same axles, but the spring rate is just lower to manage unloaded versus lowered. But even with it as a lower gower, because the whole rig weighs less, we can pull bigger trailers and put more in the box. So it actually carries more, even though the gower is lower. It's part of light-weighting.
Right, and that's the point I was trying to get, because the gower is gross axle weight rating, and I was trying to figure out why. I mean, you haven't changed anything to the axle, so the same bearings, same load carrying capability.
Absolutely.
But lowering the number, I keep thinking you'd go the other way and raise the number, but it's all part of the package.
It's part of the package and spring rate.
Picture.
We could change springs and get a much higher gower rating, but it isn't the right trade-off for the customer. This is a fantastic ride. It's controlled, it's balanced, and it's the right spring rate for the truck, and the targets for payload and trailer tow, which have both gone up.
Well, good. So for this new rear suspension, or basically new reconfigured rear end, you'll have less axle wrap, less wheel hop, so maybe you'll do better on the drag strip? Or
certainly, and the less wheel hop comes from staggered shocks. We've always had outboard shocks, which is the ideal place to put them for maximum efficiency, and now we've staggered them, and staggering them goes right back to controlling that pinion that you talked about right away at the opening of this. So yeah, and that keeps the wind-up from happening.
And in the front differential to the drive shaft is a little bit different in there?
No,
the top spleen, nothing's different?
No, that's essentially the same. So.
Oh, okay.
Yeah.
Well, I haven't crawled underneath one, so I can't remember what else is different.
Well, and we'd have to tell you what the guts are and everything else.
Yeah.
So, yeah, it's not stuff you'd see, so I wouldn't expect you to be able to pop it out there. But no, some of that's, the front end of this truck and the composure of that front end of this truck is just brilliant. And when it's under even less load. It's even more brilliant. So
Oh, well,
yeah,
good.
Yeah.
Well, we just took it off road, and I was amazed. But I was flying through there,
Yeah.
hitting big dips. We were bottoming out. We were hitting stuff you wouldn't normally do to a truck.
Yeah.
So I was trying to tear it up, and the thing didn't squeak or anything. At the end of the track, some of those trucks you get into at the end of the track,
Yeah.
the doors don't quite close right. You get a lot of
Right.
noise, and I didn't hear anything.
Yeah,
that means it's a very stiff structure.
It is. Yeah, the structure. It's high strength aluminum, but the beauty of the structure is we've up-gauged, we've heat-treated the aluminum, and just the attachments with rivets and screws. It's a stiffer structure. It's a much stiffer structure, and anybody can see that old truck to new truck. They just see one versus the other. So.
Yeah, and now you're talking high strength steel in the frame instead of calling it high carbon. It's a high strength, so it's 70,000 psi.
Yeah.
More than a semi would do. Which I thought was overbuild, but if that's something that happens because of the high strength steel, it's there. High strength steel gives you higher psi. So
and it allowed us to save weight. So we took weight out of the upper body, but we also said we're going to take weight out of the chassis and the powertrain components, because every pound you take out, you can put it back in and have the customer do the work with it.
Payload and trailer and anything. I love the big numbers. That's how I am. If I would lose some of this, I could haul more stuff. That's just how it would be.
That's what it is.
It's
a more
awesome.
athletic truck, like you and I could be, if we put the same energy into that truck that we put into ourselves. So.
Oh, great.
Yeah.
Well, thanks, Pete.
Yeah, thanks, Ken.
You bet.
All right. Good.
Okay, I'm still here with Jerry Farrell. And you're the engineer who's going to tell me what's this called now?
Well, we've got a couple features we can cycle through, just so you can see what we got and understand them.
Okay.
The cruise control is the first feature you can see in the cluster.
Okay.
We can cycle through it and probably show it to you. Collision warning.
Okay, collision warning.
Yep, so we call it an ACC, so it gives you a heads-up display if you're ready to, you're getting too close or you're coming in too fast to a vehicle in front of you. The collision warning screen or signal will pop up, and you'll get a flashing red light at the base of your windshield. Lane keep assist is another feature that we've got on our vehicles.
Is that one is okay?
Yep, so that's a feature that will, if you're starting to veer off to the left or to the right, it senses the lines on the freeway.
Okay, the cameras on the mirrors
will pick them up. Yep.
Okay,
on the mirrors.
cool.
And it'll bump you over if you're going left.
Oh, it moved. It steers you.
It'll bump you over.
It doesn't even vibrate left or right sheet on the seats.
It just bumps you over.
No audio warning or anything.
No, not for the first time.
Okay.
It bumps you over. The second time, it'll bump you again, and the third time it'll bump you again. The fourth time, you'll get an audible beeping, and a coffee cup will appear on that cluster screen.
And it knows the difference between lane changing and me just crossing the line.
Yes. Yeah.
Okay. So it has to cross the line for a certain amount of distance or time.
Yeah.
Okay.
So
Cool.
that's our lane keep feature, and we're just all here in settings. Now I've got to work my way through. Okay. So blind spot is on. So that's how you can turn our blind spot on and cross traffic alert.
Okay.
And we'll have to go dynamic here to demonstrate the blind spot and the cross traffic alert.
Okay.
And the cross traffic alert, that will alert you to vehicles coming up, crossing your path, left or right. I think it's just from the front.
Okay. So that, and when it sees cross traffic coming from the side, maybe my blind spot, it'll do what?
It'll alert you.
It'll beep at me.
Yes, it'll give you
Is
audible
there-
beeps.
Okay, any kind of a signal in the dash?
It'll also light up your orange dot on the mirrors.
Okay, so if I'm looking out backwards, it'll tell me that way too.
Yes.
Okay. So the mirrors tell me that'll tell me, and that's what's in front of me. Okay, and then what's the thing about from behind me? Is there something where it turns on the back camera?
Just the 360 camera. So the 360 camera on your center stack, that will tell you what's behind you and give you an indication when you drop into reverse. It'll give you again a left or right for vehicles approaching.
Oh, will it beep or signal?
You'll just be able to see them. It's a visual.
Oh, that's good. So I'm backing out of a parking lot. There's a truck on each side of me.
You'll be able
I
to
back
see it
out.
coming.
So that's really helpful because that happens to me all the time.
Yep.
You just keep barely scooting out, and you got a couple of Dodges on each
Yep.
side you can't see.
Exactly.
Those tall trucks.
Yep.
And that's how that works. Wow. Well, that is really good. Okay, I love the 360. So does that cover all we've been doing?
That's
there?
it. Yep.
Okay, good.
Those are all the features.
Be that hard to do. I'm not getting enough light in there. Yeah, you see that turbo boost gauge? Look at it go as I go wide open. Whoa, we're gonna run into a car. A little car is coming up. Is he gonna merge into our door? Okay, look at that. Turbo boost gauge. I love it. That is so cool. I love that on the Super Duty on the diesel.
Yeah.
Having a gauge. Okay, there is the towing mirror. This is a fancy one on a Lariat with all the chrome. And that's what they look like. Of course, it telescopes in. A little more grunt. There we go. That is the new towing mirror. It's a new towing mirror. Of course, it's different shape. Is it any so bigger than was towing mirror before?
It's about the same.
About the
glass
same size. It's a pretty mirror.
Shaped differently. It got a little bit more arrow.
It's got that fisheye on the bottom. The spotter mirror, is that bigger or is that the same?
About the same.
Really?
My goal tonight is to take you to the high-strength steel frame that we've got here. This is the backbone of the truck, as has been mentioned. It's everything that the current F-150 frame was and more. It's stronger, it's stiffer, and it's lighter. So a lot of efficiency went into the design. We got there by using a lot more high-strength steel than we had in the current F-150. We're up to 78% in this particular product, where we were 23% in the current F-150. So in the combination with selecting the right materials for the job and a lot of clever engineering, we got about 70 pounds out of the product from current F-150 to a light P22, well, I'm sorry, 552, which is the 2015 F-150. So I'll kind of walk through some of the engineering stuff that went into it besides just the materials. We'll start at the front. That's the front crush horn. I'm going to spend a little bit of time talking about this because it looks like a pretty small part, right? We were able to take about 6 pounds per side out of this part. Its job in the frame is to manage frontal crash energy. So this is what it looks like before a crash, and that's what it looks like after a crash. And a lot of engineering and effort goes into making it look like this at the end of a crash in a predictable way. So we took the 6 pounds out, frankly, by reducing the gauge of the part, the thickness on each one of these stampings, in combination with a little piece of clever engineering inspired by cardboard boxes. A typical cross-section will have a corner on each, so basically 4 corners on a rectangular section like this. We put an extra 2 corners on each one, so this is a 12-corner design. It's actually patent pending, and what it does, why it works, is I mentioned the cardboard box. Think of a box as it's basically the side of a box is 3 pieces of paper. It's got an inboard, an outside, and a zigzag piece up the middle. It's that zigzag piece that gives it crush strength. So you can stack boxes on top of boxes and they don't fall down, right? Same idea. It's by putting more corners in the edges of the frame, gives it more crush strength, which means we're able to reduce the thickness of the material, get it to do the same work. That in combination with making it of high-strength steel took 12 pounds out of the frame in total. Spent a little bit of time on that because that's kind of the philosophy that went into the whole frame design. As we work our way back in the frame, the whole thing is still the box construction that we've always had with through rail cross members. We're up to 8 now. We had 7 in the current F-150. We added one to this product, again, for extra torsional rigidity. The current front rail of the frame, which is this long piece here, the current F-150 is made out of a hydroform tube, and that means that it's the same thickness all the way around. On this particular frame, we went to an inboard and an outboard. There are 2 different stampings, which means we've got 2 different metal thicknesses on the inside and the outside. That's the strategy that was basically applied throughout the rest of the frame as well. It's all about managing gauges, putting the material where it wants to be, for strength and capability, and reducing it where we can for weight efficiency. And well over 1,000 iterations of computer-aided engineering kind of work went into that kind of an effort. I mentioned the 8 cross members. Something else we were able to do with the advent of the aluminum body, the body mounts where it attaches to the frame actually moved outboard in the vehicle a little bit. We took advantage of that space by making the rails a little bit taller and a little bit wider. By making that shape larger, we're able to, again, reduce gauge. Take out material where we can, but maintain strength. Moving back to this portion of the rail is one of the examples of tailor rolled blank. And as I mentioned up front, right, a typical stamping is one metal thickness throughout when you stamp the part. But with a tailor rolled blank, it actually varies in thickness as you go through the part. We have a kind of a pictorial of what happens here. That's going through the rolling process, being made into a coil of steel. The rollers that determine the final gauge of the steel actually adjust themselves, right? By going inward and outward. So those changes in thickness turn into a blank metal piece that looks like this, and then that gets formed into a rail that looks like this. Again, it's all about putting gauge where it needs to be, and reducing it where we can for weight efficiency. Moving to the back of the frame, this is one of my favorite pieces, frankly. This is the rail. The back rail, this would usually come out straight, and then a trailer hitch would be attached to the bottom. And the typical application, and the trailer hitch has to be low in vehicle because that's where it needs to be to hook the trailer. If you make it up high, it just doesn't work. But what you'll see in a typical application is you have a trailer hitch here with a whole bunch of reinforcements and added pieces to make that connection stiff and robust. We looked at that and said it's kind of an inefficient use of metal. So how can we do that better? And we did that by just dropping the frame rail down. So this shape of the rail, this kick down in the back, actually lines it up so that the back of the rail ends up in the same plane, same line where the trailer hitch wants to be. It allows us to get rid of the reinforcements, right? By dropping that rail down. So now the trailer hitch goes right here. So it ends up with a trailer towing system that's as capable or more than the current F-150, but you get there by using less metal. Again, put the metal where it needs to be for strength and robustness, lose it where you can for weight efficiency. So that's what I had to say about the frame, and then any questions? And if there's not, I'll turn you over to Colleen. We'll walk you through the aluminum body.
Hi everyone, my name's Colleen Hoffman. I'm the structure supervisor, and I get the pleasure of taking you through the body tonight. We have taken 700 pounds of the entire truck, right? 700 pounds, that is the size of a gorilla. So I'm going to have you come with me, and we're going to take a look at some of the parts that make that up. So the first one I want to kind of show you is our fender. So we've made our parts lighter, but we've also reinforced them to make sure where the customer's using it that they still get that same truck feel. But I want you guys, someone's got, go ahead, pick that up. Yep, and you guys can pass it around because I want you to get a feel for what aluminum is.
That's pretty cool. I mean, I didn't expect,
Yeah.
I expected it to. Yeah, I was like, are you sure you want me to hold that?
But we've also made sure, because it's a lighter material, we've made sure that our structural members, this is the front of the vehicle, this is our hydroform front tube, that the gauge is enough that holds the robustness again of the truck. So we've taken this technology, and I'm going to pass this around too. And I'm going to start back here as well, but this is heavier, so don't expect that. But it's lighter than it would be in steel.
Not very heavy. That's awesome.
And we've taken that technology and we've put it on all the way up the A-pillar and throughout the cab, right? So we have a good, strong cross-section here in order to make sure that roof cush, any kind of safety related items, that we're making sure that we are strong and robust. And I'm gonna let you take a look at that as well, because you can see in here the sections, right? And you can see how that's really a strong, robust piece. Another structural panel that I want to take you through is down in the rocker. right? We want to make this strong for any kind of intrusions, anything that you would see from the side of the truck. It's got a nice box section for it, right? And again, this is an extrusion technology to make sure that we have that continuous. And if you don't mind,
I don't mind.
thank you very much. And our panels wouldn't be anything without a good joint, right? We want to make sure that our panels are laying next to each other, that they're bonded well. So we put adhesive throughout, and we also use riveting. That is a change from the steel technology. We used to weld, and now we use specific rivets. And you can see that we're able to join, this would be up in the B pillar area, a thinner gauge to a more structural area again. So I'll spare you from passing this one around. Our aluminum has gone through heat treating as well, make sure that it's very strong. It's the military grades, but this is a proprietary process that we have to make sure that we're not making just a lighter truck, but we're making a robust truck. So I want to talk a little bit about bed, because when we designed this truck, we wanted to make sure that we were getting the customer's usage. So we gave it to people that were in gold mines and construction, and we told them to use it. In fact, what we did is we took the current truck and we gave them a bed in aluminum and didn't even tell them. So we told them to use it the way that they wanted to use it, throw in all of their metals, and we redesigned our test to make sure that it held up. And in fact, we even discovered that we would upgauge the floor of the bed just to make sure that it held up. In our bed, we have reinforcements. I'm sure in the next, you'll be going through some of the accessories in the bed as you're touring through. They will take you through BoxLink, and they'll take you through what they do with E-Link, but I wanted to make sure that you saw that there was a good reinforcement in here. And with E-Link systems, we're able to take 250 pounds across the back of the bed and 600 in front. Do you have any questions?
Dealer-owned body shops and independents that have been trained. We completed the training in August, and they've all got the equipment. Some of them already have the equipment installed. All of them will have it installed by November, and we'll be ready to go. We'll deliver the same coverage that we do today. And there's a lot of smart engineering in the truck as well, so that you don't have to replace as big of sections when there is a structural damage, saving costs, and also you can do it more quickly. You don't have to take as many, like there's a repair where today where you have to take the instrument panel out. You don't have to do that because you can section the piece and get to it and replace it much more quickly. So that will also reduce the cost, the labor cost of the repair. Thank you.
And if there's no other questions, we're going to turn it over to Ed, who's going to take you through the new 2.7 liter engine.
Yes, my name is Ed Wishenko. I'm going to talk to you about the new 2.7 liter engine. It's a direct injected twin turbocharged V6 engine that puts out 325 horsepower at 5750 RPM and 375 foot-pounds of torque at 3000 RPM. And it's actually, I think it's great that you guys are talking to us before you actually have a chance to drive these vehicles. But the heart of the engine is really the cylinder block, and the cylinder block is another example of what I would call smart material use. The cylinder block is made out of compacted graphite iron, also known as CGI, and the reason we've chosen compacted graphite iron is because it has twice the tensile strength of conventional gray cast iron, and what that allows us to do is to have thinner wall sections in the casting. The other thing that's unique with our cylinder block design is we cast the main bearing caps as part of the cylinder block. The main bearing caps are then laser notched and cracked with a mandrel, similar to our connecting rods process where we take a connecting rod and fracture split the cap. And the advantage of that is, one, we don't have a separate bearing cap castings in the engine plant, and two, it gives us really the almost like an intermolecular fit between the bearing cap and the main cylinder block when we bolt in the main bolts. The 2.7 liter also has, it's not shown here in our model, but it has a composite oil pan, composite cam covers, and composite intake manifold. It also features a variable displacement oil pump. And the variable displacement oil pump lets us tune the oil pressure for what the engine needs. And we monitor coolant temperature, oil temperature, speed and load, whether you're towing, driving down the freeway, etc. So we have the VDOP is what it's called, calibrated to minimize the parasitic loss, again, to get better fuel economy. Tomorrow you're also going to experience start-stop. Start-stop is standard on the F-150 with the 2.7 liter engine. Because of the start-stop, we've had to design for it. It's a difficult, a tough durability cycle for the engine bearings and connecting rod bearings. So because of that, we have our bearing system in our lube package has a extremely hard IROX coating is what it's called, that is seizure resistant. We also test for the start-stop cycle that you guys will be able to drive tomorrow, and that test cycle is 240,000 stop-starts on the dynamometer. The engine also features aluminum cylinder heads with integrated exhaust manifolds. So the integrated exhaust manifolds allow us to move the turbocharger as close as possible to the exhaust ports. So we don't have a separate exhaust manifold that then bolts the turbocharger to it. It also helps us make the engine more compact. What you'll see when you drive the truck is really a extremely responsive engine. It's fabulous as far as time to torque goes, or lack of turbo lag, because we've made the air path from the turbocharger to the charged air cooler and back in the intake manifold as short as possible. The front cover is what we call highly integrated. Highly integrated really means that that's where we have our cartridge style oil filter, making oil changes easy, the water pump, thermostat housing, and the controls for the oil pump. The connecting rods in the engine are also, I would call them diesel-like. They are offset I-beam designed for the cylinder pressures that is needed to provide 325 horsepower out of a 2.7 liter engine. The connecting rods also feature a bushingless design on the pin end, which is another first for Ford, along with the cracked main bearing caps. What we are able to do with that technology is make the engine shorter by approximately 3 millimeters by eliminating the bronze bushing, which is typically inserted into the pin end of the connecting rod. We actually machine in the profile of the connecting rod. It's not a straight cylinder, to simulate the pin bending under piston pin bending under firing loads. We have the engine's direct injected, as I mentioned. It has a high pressure, common rail fuel system. Uses 6 quarts of 5W30 oil. 100,000 mile spark plug change intervals. One other thing I was going to mention is to prove how tough our new truck is. We took the truck to the Baja 1000, and we took it to the Baja 1000 disguised as a current production F-150. We did that with the powertrain that you're going to drive tomorrow, and really the powertrain that you see here. This engine, the transmission, driveline, 4-wheel drive system, transfer case are all production level. The truck was not a race truck. It had all the underhood. It had a production exhaust system, air cleaner. We just put a safety cage in it, along with a large fuel cell, so we can make it from pit to pit. And we finished the race 883 miles, the longest Baja 1000 in the history of the race. And from Ensenada, we decided, without any issues, by the way, we decided to drive it back to Dearborn, Michigan. So we put a plexiglass windshield in it and drove it back from Ensenada, Mexico, back to Detroit, and it was in the auto show, basically right from Mexico, unwashed, with all the mud, dirt, silt, etc. So I was able to go along and chase the whole 883 miles with parts and technical support. It was really not necessary, believe it or not. So it was fun for me. But anyway, just proving how tough our new truck is and how good our design is. You guys have any engine-specific questions, or? Yes?
So the VDOP, is that an electrical savings that gives you fuel efficiency, or what?
No, it's a parasitic loss because we're driving the oil pump. You know, it's mechanically driven with a, you guys can come over here if you like. I mean, a primary drive is a chain, it's all a chain drive. So we have the primary drive consists of the two left and right hand primary chains. Then the oil pump is driven here by a separate chain and tensioner. So really, it's the parasitic loss as we're not, you know, delivering, for example, 75 PSI, you're delivering 35 PSI, just for, you know, talking purposes. And so the less pressure you need to deliver, the less power it takes to turn the pump.
How similar is this to the Mustang EcoBoost engine?
The Mustang EcoBoost engine, it's not similar at all.
No,
It's a completely different
totally,
engine. This is a clean sheet, brand new design.
That's awesome.
Not common with the
Similar horsepower, but it's like
that's an I4. This engine's not common. Does not have any common components with like the 3.5 liter EcoBoost. It's a whole new engine family.
My name is Lana Strager, and I'm responsible for innovations on the F150 team, and I'm going to show you some of those that we did on this truck now. First, we have a power tailgate lock, so when you lock your doors, you're also locking your tailgate. Then we added a remote tailgate release with a dampener, so all you do is double click on your key fob and the tailgate comes down very nicely and easily. The next thing we did was we wanted to preserve this workspace as a flat workspace. And in the past, when you had a tailgate step, you had a handle here and it was a little bit in the way and it would come up and it would go down. So instead of having that here, we preserve this workspace and we put it in here. So your tailgate step now housed inside your tailgate and your tailgate step handle now housed inside your tailgate. And you step up into your truck. We added, for convenience of our customers who primarily have soft tonneau covers and can't use the cargo light to illuminate the inside of the box, we added LED lights that are very bright and shine into the center of the box, but they're tilted so that they don't shine in the face of the person who's trying to do some work here on the tailgate. The key thing that people ask for on a pickup truck is more tie downs, bigger tie downs. So in addition to the 4 tie downs that we have, we've kept those and we've added 4 more. And we add them in the mid of the box and we call this system the box link system. And box link consists of a very heavily reinforced box side inner. On side of that reinforced inner we put this plate. We call this the interface plate. And you can connect directly to that plate via S hooks or bungee cords, or you can use the standard E-Track system that people use in their trailers with the E-Track fittings. We made these plates compatible with the E-Track fittings. For most of our customers, these cleats are going to be just fine. They're an easy recognizable shape, which is the shape of a boat tie down, and they go into the box link system one-handed and they're locking. So you have your boat tie down, they go into the plate, they snap in one-handed, and they have a locking mechanism here.
Can you do that again?
I can.
Cool.
And you can S-hook, ratchet strap right here in the middle, and then you can use these outboard holes for secondarily tying down. The beauty with the box link system, and the reason we did this, is we wanted to be a platform and facilitate our customers and the accessory suppliers. So using this plate, you can add customized accessories. Ford, we're offering this bed divider. You put the bed divider in this location, you can put the bed divider in the Ford location, and that keeps things from rolling into your box. If you have a tile or concrete or groceries that you don't want to roll down, you want to keep them up, the bed divider does that for you.
How many positions does the bed divider do?
Right now it does here and here.
Okay,
so 2,
okay.
Yep. And then we also have stowable ramps, so for driving up dollies, driving up ATVs, motorcycles, and those also use brackets that link into the box link. There's 4 brackets to go into the 4 box link plates, and it's like a ladder rack. It's a hook, and then you slot the ramps in, and then you lock them to the vehicle, and those are in the other truck.
Okay, we'll look at those right quick.
So another feature that's links right into the box link system is the cargo ramps, the stowable loading ramps, and you put these brackets into the BoxLink system. There's 4 brackets, and when you're done doing that, it looks like this. You just slot your ramp right in there, and it's really safe, secure. It's also lockable. When you get the ramp kit, you also get the plate that goes onto your tailgate, and that plate has a roll form on the end of it. And the reason why it has that is because a big frustration of customers is when I drive my motorcycle up here, sometimes my ramp will come loose and it will come away from the tailgate, and we don't want that to happen. So we've made this positive retention, so no matter what angle you put your ramp, it will not come away from your tailgate. You can do it way up high, like a loading dock, your porch, or a hill, or whatnot. And they simply slot into the side of your truck, right? One side or the other, they slot in, and then you put them in any position that you want. Once you put the weight on them, they stay in position.